Welcome back, everybody. 4.8, we're almost there. We got one chapter left after this section. Hang in there, folks. This chapter or section is brought to you by Rolls, not the candy. Rolls theorem and MVT, mean value theorem. So let's just say what Rolls theorem is. Just get straight to the punch. We'll draw a picture for it in a second. Let f of x be differentiable on AB. Some open interval AB and continuous on the closed interval. So endpoints are included. If f of A equals f of B, then there exists and I'm going to use this exists, there exists a bunch today. The mathematical symbol for there exists is a backwards capital E. Then there exists some point C or some value C in AB such that f prime of C equals 0. That B. Just wanted to make sure they look like they're at the same height. So that is f of A, which is also f of B value. There is some point C in this region such that f prime of C equals 0. We'll go through a proof of it. Some books, and I think our book does it, some books say f of A equals f of B equals 0. But that is not required. The equals 0 part is not necessary at all. Just that f of A equals f of B. Now, we're saying f of x has to be differentiable because we want to make sure that when we take the derivative and find critical points, as you'll see, that it's not some cusp or something like that. We want the derivative to actually exist at the point. Because a cusp is a critical point, but it does not have a derivative equal to 0. Give you another 30 seconds, then the show will go on. You guys ready? Does anyone need that longer? Okay. All right, so we're going to prove this. Given three things, f of x is continuous on AB. F of x is differentiable on AB. And f of A equals f of B. And what we're trying to prove, we want to show there exists some C in AB such that f prime of C equals 0. Case 1, maybe he's showing illustrationally what's happening. There's three ways to go from f of A to f of B. Case 1 is just a straight line, connecting the dots. Case 2, we leave f of A with a positive slope. We got to come back down to it. Because it's continuous and differentiable. Case 3 is we have some negative slope coming out of A, but eventually we come back to it. So case 1, f of x equals a constant for all, and we use that for all. for all x in AB. And this is a freebie. The derivative of a constant is 0. Case 2. We have f prime of A is greater than 0, or effectively, there is an x we'll call it x naught in AB such that f of x naught is greater than f of A. Like that, some point like that. It doesn't have to be the endpoint. The point is that there is a value above the 2 points. Since f is continuous, and f of A equals f of B, which is less than f of x naught, by the extreme value theorem, there is a max. There exists a max in AB. And it's not one of the endpoints, because we have some f of x naught, f of x naught in there that's high, has a higher value. And we'll call that max C. This makes C a critical point. Critical points have 2 scenarios. From critical points, we either have f prime of C equals 0, or f prime of C does not exist. But since f is differentiable, at C, it's the f prime of C equals 0. The DNE happens when there's no, we can't do the derivative there. At cusps and vertical lines and stuff like that. Case 3, we'll have an x naught down here. We will leave case 3 as a proof for you to do. In fact, take a couple minutes right now and do it. It's similar to case 2, but give you some practice doing it. Try to write the proof for case 3 using case 2 as a model. Here we're looking obviously for something that's lower, so therefore a minimum. I told you guys Tuesday I'd let you know about Veterans Weekend for Mesa. I will be at the Mesa Center on Saturday on Veterans Weekend. I know it's Veterans Day that day, but you guys aren't having to work. I'm working and it's voluntary. And maybe, just maybe, I'll be helping some veterans descendant. All right, did you guys go through and do it? Get it figured out? Since F is continuous, and F of X naught is less than F of A, which is F of B. Alternatively, you could say F of A equals F of B is greater than F of X naught. By the extreme value theorem, there exists a min C in AB C is therefore a critical point. And since F of C is differentiable, well, since F of X is differentiable there at C, F prime of C equals 0. Anyone need that? I see some heads going up and down, so a little bit longer. You guys ready? Esteban? Good. All right, before I give an example, I want to share just for some humor, a couple images that were sent to me this week that really made me smile. Now, if you haven't seen Star Wars and you don't know what's going on in the bottom scene, rather than tell you, I'll let the next image tell the joke. That made me smile. I would love to do that. So in the other one, Anakin goes full Sith Lord and goes and slaughters all the Jedi children with a lightsaber. That's what happens. Spoiler alert, it's been out for a long time. But if I could do that in a VR game, and necessarily gotta have Force lightning, gotta do some Palpatine shit. I need that. I want that. All right. Bad guy. I like bad guys. Fuck Luke Skywalker. You little bitch. Lord Vader. Let's look at an example. We want to verify we're talking about Rolle's. Verify Rolle's theorem for f of x below and find c. F of x equals 1/2 x minus the square root of x on 0 to 4. So we need three things. We need f to be continuous, differentiable, and we need the endpoint f of each endpoint to equal each other to satisfy Rolle's theorem. So 1 is f continuous, at least on 0, 4. Well, 1/2 x is a continuous function. And square root of x is continuous as well. And the sum of continuous functions is continuous. I guess if I want to say sum, I need to say negative square root of x. Because I said adding. So 1/2 x and negative square root of x are both continuous. Then and sum of continuous functions is continuous. I didn't finish my thought there. Is f differentiable? How can I prove that? I need to show that's true. How can I do it? Anybody? Home audience? How can I show f is differentiable? Just take the derivative. That was kind of a trick question. Just take the derivative. You might find it easier to rewrite this as 1/2 x minus x to the 1/2, so that f prime of x is 1/2 minus 1/2 x to the negative 1/2. And we only require it to be differentiable on AB, but not the endpoints. Like plugging in 0 here, one of the endpoints causes a problem, but we're not looking at the endpoints. We don't need it to be differentiable at the endpoint. We can't do f prime of 0, but that's not a problem. So we were able to take the derivative and it works on 0 to 4. I'll put in that little caveat on the open interval 0 to 4. Finally, third thing, does f of A equal B? F of B. Or in our case, does f of 0 equal f of 4? F of 0 is 1/2 times 0 minus the square root of 0, which is 0. F of 4 is 1/2 times 4 minus the square root of 4. 2 minus 2 equals 0. So f of 0 equals f of 4. And we met all three requirements. So how do I find that value C? Was supposed to say for f of x below and find C. My words and my pen did not line up.
Do a sign chart?
We can do that. But a sign chart around what?
Between 0 and 4?
Okay. Well, we're saying there's some value in the middle that's going to have a slope of 0. Rolle's theorem is going to tell us there's a point somewhere in between 0 and 4 where the slope is 0, and which means part of it's going to have, I mean, they're either both going to sign chart on f of x, on f prime of x. Like, we need to find where C is at first.
Well, would it be that you take like the take the derivative and then set that equal to 0 to find the value c?
Exactly, Dalton. Holy shit, I didn't even know you spoke.
Huh.
No, I'm teasing you. All right, yeah, and we already took the derivative. We have it up here. And we're going to set that equal to 0. I can add the 1/2 root x to the other side. Now, if you really need to go through with it, you can. We can clear fractions. And we get square root of x equals 1, which means x equals 1 when you take this, when you square it. Of course, I think you could easily hopefully see and argue if the left side is 1/2 and we've got a 1/2 here already, the only way this matches this is if this value equals 1. For them to both be 1/2. If x is anything but 1, this is not 1/2 anymore. Or you can clear the fractions like we did. Now, if we wanted to find if it was a max or a min, this is where we could do a sign chart on the derivative. And why not? It was in this chapter. This sucks. I gotta put on 1/2 in here. You know what? I'm gonna put 1/4 because I can take the square root of 1/4 pretty easy. Actually, if you get a common denominator here, this is square root of x minus 1 over 2 square root of x equals 0. That's getting a common denominator. And the bottom is always positive. When x is 1/4, the square root of 1/4 is 1/2. 1/2 minus 1 is negative. And square root of 2 minus 1 is greater than 0, so this is positive. So the slope was going down, then it's going up. It looks like x equals 1 is a min.
So is x equal 1 equal to f of c?
X is c, or 1 equals c, yes.
Okay.
That's so apparently. It's coming down like that, and it's got a min there at 1, and it's doing some shit like that. You have a question, Cohen? Guess not. His mic popped off for a second.
I had a question
Yeah.
not exactly related to this, but on some of the homework, it's asking for a second derivative test. is that always necessary when you're solving? What's the point of doing it?
The second derivative test shows concavity. We did it in one of these sections.
4.2.
Okay. It shows concavity. So if the second derivative is greater than 0,
The first derivative shows increasing, decreasing.
so in the for f prime of x shows increasing and decreasing.
Okay.
Is that what you're asking?
Yeah.
Okay, so there's a couple ways concavity goes.
Okay.
This is concave up.
Right.
That is concave up, that is concave up. And okay, so here, if you had increasing and then decreasing, you should show this should not match that. Here, f double prime of x should be less than 0 because it looks like it's making a pull downwards.
Okay, down.
So f prime of x, double prime of x, less than 0 is downwards. F double prime of x greater than 0 is upwards. But both of these have increasing concavity. Here, f prime of x is less than 0. Here, f prime of x is greater than 0.
That answers my question, because I was just wondering what double prime of x.
Okay, what it does, okay.
Thank you.
Now you can have concavity sometimes, well, at a critical point like this, sometimes concavity changes. Like here, not concavity. This is a critical point and concavity doesn't change. The slope changes, goes from negative to positive, but the concavity stays up. You can have a concavity switch without the derivative changing. If you have like this, that's a critical point. F prime of x is greater than 0 along the whole thing. I'm off the screen. But this part right here is concave down, and that part right there is concave up. So you can have concavity shifts. And the second derivative shows that. So it'll show you the curvature.
Got it.
Okay,
Yep, thank you.
let's take a 5-minute break. When the second derivative is a single number like 2, what does that mean? It's all dependent on the sign. It doesn't matter the value so much. The greater the value, the more concave it is. Cohen asked.
So does that mean it's like concave up the entire time?
If it's positive 2, yes, it's concave up the entire time.
Thank you.
If it's negative 2, it's concave down the entire time. Like negative x squared would have negative 2 and x squared would have positive 2. All right, let's take a 5-minute break, give people potty bathroom break. All right, so for the mean value theorem, I wanted to show like how it relates to Rolle's theorem before we switch over to mean value theorem. Notice how if we look at the line from f of a to a through b, this is like the secant line through AB, through A and B. what is the slope of this line? If f of a equals f of b. This is some calculus shit. This is basic algebra. Rise over run, baby. 0. These two have the same derivative. Same derivative. Well, what if we turn the graph a little bit and make it sideways a little bit, like something like this? Wait, you were writing that. I kind of yanked it away. Like once I motivated the thought, I yanked the page. Let me finish writing. This is motivating the mean value theorem. You will find this several times throughout mathematics. There will be one theorem named after another guy, one guy, and then like a second theorem that is a more general theorem that sometimes is named after a second person, and sometimes just has a name like mean value theorem. So all we did is added that the derivative of that secant line is the same as our line up here. All right, you guys ready for some more magic? The mean value theorem. This is what you know get tattooed on your forearm because it's that fucking important. Lovingly known as MVT. Let f of x be differentiable on AB, the open interval AB. And continuous on the closed interval AB. Then there exists at least one point C in AB where f prime of C equals f of B minus f of A over B minus A. So our blue line is our f of x here. The curve. I'm going to call the secant line here g of x. So what the mean value theorem says is if we've got 2 points A and B, then the slope of the line going through them, the secant line going through them, there's some point in AB that has the same slope. That's what it's saying. So it's saying basically at some point, G prime of C equals F prime of C. The slope of G at C is the slope of F at C. To prove this, we're going to create another function. We're going to call it b of x. Let's call b of x f of x minus g of x, which is effectively finding the difference in these heights. This is v of x. V of x is modeling this height difference. So that is v of x. At C, it's right there. But b of x will just track the height difference throughout it. And oddly enough, well, coolly enough, V at C is a maximum, is the max height difference between F and G. That's where it gets the biggest, right there. So that's going to be the motivation for our following proof. At x equals c, the vertical distance is a maximum. Between F and G is maximized. And so we will find an equation for this. For b of x and examine it. Okay. So let's look at our proof. And let's keep the image of our graph over on the side so we can take a look at it while we're gone. So let's take a look at g of x. What is g of x? Well, g of x is a line. So we can write it as y minus y naught equals m times x minus x naught. Right? That's our point slope equiline form of a line. I don't want to find the y-intercept. That's too much work. We've got 2 points already. That's why I chose this point. We have a, f of a is a point. And we have b, f of b is a point. So we can use those to get a slope. M equals y2 minus y1 over, let me write it below. Y2 minus y1 over x2 minus x1. And we got to pick a point to plug in. I will pick, let's go with that one. We'll plug that in and that in up here. Y is really g of x for this line. So putting that all together, y is g of x minus y naught is f of a equals m is f of b minus f of a over b minus a. And then we have x minus x naught is a. There's a lot going on there. That's y minus y naught equals m times x minus x naught. I want to make sure you see where I got every piece from. Everyone good with that so far? Yeah,
Wait, so would M also be F of C?
m is f primacy.
Okay.
So that is f primacy as well. So we have this. If I solve this for g of x, G of X equals f of B minus f of A over B minus A times X minus A plus f of A. And I want to make it clear, this is the only variable. Everything else is a number. This is y equals mx plus b form right now. It just doesn't look like it. It's not cleaned up. And the formula for that vertical height is f of x minus g of x. So we're going to plug in what we just got for g of x.
Bx equals fx minus gx.
Did I mean to put that?
Yeah, or
Yeah.
like, you know how you put fx minus fx, you mean fx minus gx?
Ah. Yes, I did mean fx minus g. I said it and then I wrote fx minus fx, which is just be zero, right? Thank you for calling me on that fucking stupidity. That didn't make any sense whatsoever. You're like, okay, the vertical height is zero the whole way. Excellent. Done and done. You even said it and I looked at it and it still didn't translate. I'm like, what is wrong? I don't know what he's talking about. And then I looked a third time and I saw it. All right, so this is our vertical function. It's continuous. We can see it's continuous. It's differentiable. What is VA and VB? Find V of A and V of B real quick. And remember, X is the only variable. So you're plugging in there and there. Plug in B. This becomes B minus A, cancels out that bottom. And we have that. And the negative FA and plus FA cancel out. You've got F of B minus F of B is 0. So VA equals VB, which equals 0. Almost done. So to wrap that bad boy up, V of X is continuous and differentiable. Well, continuous on AB, closed interval, and open interval for differentiable. And V of A equals V of B. So a Rolle's theorem event triggers. This means there is some C in the middle where V prime of C equals 0. Or some, or at least one C. Point X equals C in AB. So what is V prime? We had Vx equals f of x minus f of b minus f of a over b minus a times x minus a plus f of a. And the only x's we have here are there, there, and there. So when I take the derivative, v prime of x, it has to equal f prime of x. And what's the derivative of x minus a? It's the derivative of x. It's just 1, right? 1 times this. That's v prime of x. And B prime of C equals 0 says that F prime of C minus F of B minus F of A over B minus A equals 0. We solve for F prime of C. And that's the mean value theorem. Yeah,
Does the plus, F of A go away just because of the constant?
yes.
Okay.
Yeah, that's why I made sure to emphasize, there's a lot of shit going on here, but we want to, like, where are the actual variables here? Just the x's. Everything else is a constant. You guys ready to do an example with it? Does anyone need this page up longer? Speak now or wait until it's up on uploaded. All right. So let's look at an example. We're gonna let f of x equal x cubed minus x squared plus 1 on -1 to 2. Find all the values satisfying MVT. The mean value theorem. All right, step 1. First off, show it meets the conditions. A, f of x is a polynomial and thus continuous. B, f prime of x equals 3x squared minus 2x, which shows that f of x is differentiable. We meet the conditions, so let's take a look and find f prime of c has to equal f of b minus f of a over b minus a. It looks like a equals -1 and b equals 2. So f prime of C equals f of B. 2 cubed minus 2 squared plus 1 minus -1 cubed minus -1 squared plus 1 all over 2 minus -1. It's a 3 on bottom. This is 8 minus 4 plus 1, and then minus, we've got -1 minus 1 plus 1. So 4 plus 1 minus a -1 over 3. Thank you. Equals 2. F prime of C equals 2. Thank you. I got a tickle in my throat. And what's F prime of C? Here's F prime. So F prime of C is 3C squared minus 2C. That equals 2. So that 2 came there. This came from using F prime of X and evaluating it as C. We're going to solve that. We'll get the 2 over on the left. 3C squared minus 2C minus 2 equals 0. C equals -B, which is +2, plus or minus B squared is -2 squared, minus 4 times 3 times -2, all over 2 times 3. That 2 plus or minus the square root of 28 over 6, or 1 plus or minus the square root of 7 over 3. If we simplify that, that's 2 root 7. This generates 2 C's. Which ones are in our region? Where's my trusty calculator? So 1 plus square root of 7 divided by 3. I'm getting C is approximately 1.21. 1.22 if I round correctly. 1 minus square root of 7, and then divide by 3. Or C is approximately -0.55. Both of them are in -1 to 2. So both of those values will work. And these are X values. Yeah,
It's gonna have 2 slopes.
there's going to be 2 points where it has that slope. Yeah, Matthew.
So when you set 2 equal to the derivative, you remind me why we did that?
Because this is what the means value theorem says. There's some point F prime of C that has the same slope as the secant line. So we found the secant line, or the slope of the secant line, it's 2.
Yeah.
And so F prime of C equals 2. We're looking for the values of C that work. So we have to plug in C to see what we get.
Oh, okay. Gotcha.
Got it? I mean, I think plugging in the C is optional. You could just do it with X, so it looks like your standard X equation with X. But I wanted to make sure everyone was tracking that I was actually going with C.
Okay.
If I were to do this by hand and no one was watching, I would just use X. Any questions? Let's go back to that problem we had before. Well, does anyone need this up longer? See a couple people still writing. Let me get a second. Give me a second. With the first one we started off with was f of x equals 1/2 x minus square root of x on 0 to 4. We did it with Rolle's theorem. Let's show it with mean value theorem. Everyone good? Good writing this? Okay. So we're going to use MVT for our Rolle's problem, the first Rolle problem we did. We already showed for the Rolle's problem, it's continuous and differentiable. And we showed f of 0 equaled f of 4, which equaled 0. So when we do, f prime was 1/2 minus 1 over 2 root x, which is square root of x minus 1 over 2 root x. We want to set that equal to f of b minus f of a over b minus a. We already show, well, f of b is f of 4 minus f of 0 over 4 minus 0. We already showed those two were both 0 though. So the right side here equals 0. And we have square root of x minus 1 over 2 root x equals 0. Nope, not the way I wrote it. Square root of x minus 1 like that over 2 root x. At this point, I should probably be using C, just for the point of this lecture. But see how I naturally kept it as x. Because right now we are evaluating f prime of c. F prime of c equals f of b minus f of a over b minus a. Well, c does not equal 0, so I can multiply through by it. And I get square root of c minus 1 equals 0. Square root of c equals 1. So c equals 1. And that's what we found with Rolle's theorem. Yeah,
Rewrite that. What would you have to write it that way?
well, to make it usable.
Yeah.
You wanna have, like, not have the negative exponent.
Okay.
Like, when I took the derivative. We had 1/2 minus 1/2 x to the negative 1/2. But in terms of like. Solving, using it later on, that's not usable.
Yeah.
I chose to find a common denominator, but you could have gone through with this. Without finding a common denominator. You would have the right side equal 0. So 1/2 equals 1/2 root x. Clear the fractions and you get square root of x equals 1. Like we did on Rolle's theorem. All right, so that's it for 4.8 lecture. Is everyone done writing? I want to show you the review for a second. The review is up in the modules. It's got a few problems, more than you would have to do on an actual exam, but it gives you ways to stuff to practice absolute max and min, practice curve sketching, doing your concavity and all that good stuff. There's Rolle's and mean value theorem up top. Some questions that you're going to find challenging are 6 and 7. I haven't looked into solving 7 yet, but number 6 says, find the point on the hyperbola xy equals 8 that is closest to the point 30. We only got a few minutes. We're not going to be able to finish it, but I want to motivate the idea for like something you guys can go with. So on review, it says, find the point closest to 30 on the hyperbola xy equals 8. Now, this might take you a while to think of. What are we trying to minimize here? The closest is closest. If we're finding the point closest to it, what's going on here? I don't know what the hyperbola looks like. Let's say it's something like that. But we got some point here. Maybe that's 30, I don't know. There's lots of distances to here. We want the shortest distance, D. So we want to minimize D. D is y2 minus y1 squared plus x2 minus x1 squared.
Do you know that?
The distance formula?
Yeah.
That's basic algebra. Or if you don't want to do basic algebra, the distance between 2 points, between this point and this point, c squared equals a squared plus b squared. So the length of c, the shortest distance between point 1 and point 2, is the square root. And I think at this point, I would say y1, I would use this as x1, y1. And say this is 3 and 0. I don't know what my x is, but I can solve this in terms of y, and y equals 8 over x. I would do 8 over x right here. And I would say I'm trying to minimize that. The other one says the largest circular cone that can be inscribed in a sphere of radius r. I'm gonna have to think about that. I don't know the fucking equation of a circular cone. I'm pretty sure it's just like a snow cone shape. But I gotta look, so I don't have an answer for that one right away. But the review is gonna be harder than the exam. I'd like to think the last review was harder than the last exam. And we will have a test on Tuesday. Or option, we can start chapter 5 on Tuesday and do the test on Thursday, which gives you a little bit longer to get finished, get caught up. Who here wants to test on Tuesday? Who here wants to test on Thursday? All right, we'll do the test on Thursday. I'll make an announcement. I'll make an announcement right now. And that's what we'll do. And that's 11:09, it looks like. We'll start chapter 5 on Tuesday. But this gives you a couple more days to prepare for the test. I'll see you on Saturday, Cody. Anyone else that wants to go to the Mesa Center over in Visalia, John Muir Building, 9 to 12? No, the day of the test. Cody asked if the homework will be due on Tuesday. No, day of the test. No problem, Ainsley. See you tomorrow. Have a good day, Cody. They all concurred Thursday.